So line spectrum of hydrogen atom is our topic today. In the previous class, we have seen equation for energy of an electron in nth orbit or an nth level, and we have got equation En is equal to m minus m e raised to 4 by 8 epsilon 0 square h square n square is the equation that we have seen in the previous class. When you substitute the values of the constants except n square, we have got a value minus 13.6. Then it is in EV. The unit is EV, not in joule. The unit is in EV. We have got a value. Now, if we put n is equal to 1 here, what will we get? We will get E1 is equal to minus 13.6 EV. If n is equal to 2, you will get minus 13.6 by square of 2 is 4. What is the answer? Minus 3.4 EV, and so on. We can get n is equal to 3. You will divide by 9, you will get 1.51. N is equal to 4, we divide by 16. Square of 16, we will get minus 0.85 EV. These are called energy levels. This corresponds to ground state, first excited state, the second excited state, and third excited state, and so on. Now we can represent n is equal to 1, the ground state, n is equal to 2 is the first excited state, n is equal to 3, n4, n5, n6, n7, and so on. These are the higher levels. Okay. Now we need to see what happens when an electron jumps from a higher level to lower level. For example, an electron in the excited state can come back to lower level. What happens during the process? During the process, the difference in energy between these two levels will be emitted as photons. Okay. Now there is a famous relation for the wavelength of photon emitted. That relation is called the Rydberg formula. We are going to see the Rydberg formula. So in this equation, we will give n is equal to n1. Instead of n, we will give n1. Okay. What is the equation now? Minus m e raised to 4 by 8 epsilon 0 square h square n1 square. Similarly, we put a n2 in the term of a n1 n. So what's the equation? Minus m e raised to 4 by 8 epsilon 0 square h square n2 square. Okay. What is the difference in energy? This is a higher energy. En2 minus En1 we subtract. When we subtract this, you will get here except n1 square and n2 square are common terms. Which are the common terms? Minus m e raised to 4 by 8 epsilon square h square is common term. Inside a bracket we have 1 by n2 square minus 1 by n1 square. Minus also taken outside. Take the minus inside. M e raised to 4 by 8 epsilon 0 square h square into 1 by n1. You will reverse this. 1 by n1 square minus 1 by n2 because a negative is taken inside. 1 by n1 square minus 1 by n2 square. Now this change in energy, difference energy is equal to h nu. Because delta A should be equal to energy of the photon. Photon has energy h nu. H nu is equal to c by lambda. So we can write h c by lambda is equal to m e raised to 4 by 8 epsilon 0 square h square into 1 by n1 square minus 1 by n2 square. Okay. So what is 1 by lambda? To get 1 by lambda h and c we have to multiply here, cross multiply. So m e raised to 4 by 8 epsilon 0 square h square and h cube, and one more c comes here. When evaluate these constants, we get a constant value. This is a constant value. This constant value is named as a Rydberg constant, or we can say R. So what is the value? R 1.03 10 raised to 7 meter raised to minus 1. This famous relation is called a Rydberg formula. Okay. Now we will see different spectral series in the line spectrum hydrogen atom. Electrons can undergo transition from higher levels to n is equal to 1 level. Such series is called a Lyman series. Means from 2 to 1, 3 to 1, 4 to 1, etc. From higher levels to level 1, transition is possible. These spectral lines are called a Lyman series. So what's the condition? N1 should be 1, N2 should be 2, 3, 4, etc. This will lie in UV region, in ultraviolet region. Okay. Now next we will see Balmer series. In Balmer series, the transition is to the level n is equal to 2. From 3, from 4, from 5, etc. This is called Balmer series. Balmer series lies in visible region. So here n1 is equal to n2 will be 3, 4, 5, etc. Now what is Paschen series? In Paschen series, the transition is to the level n is equal to 3. n1 should be 3 here. Means to level 3 from higher levels like 4, 5, 6. It is called Paschen series. It lies in infrared region. Then bracket series. In bracket series, lower level is 4. So to the level 4, transitions are there from 5 and 6. And from other levels also we can represent 5, 6 and 7. there is transition. These series are called bracket series. So Paschen and bracket series lies in infrared region. Another one is called P fund series. In P fund, N1 is equal to 5. So lower level is 5. To the level 5, transitions from 6 and 7 or from 8. That I have shown there. But transitions are possible. These level series are called P fund series. This lies in far infrared region. Okay, so we have seen the spectral series of line spectra of hydrogen atom, and this is the famous equation called Rydberg form. Okay, which is the spectral series lying in visible region? Only Balmer series. So this is only visible for naked eye, and these series are not visible for naked eye. Lyman series in UV region, Paschen and bracket in infrared, and P fund in far infrared region. Okay, thank you.